If you'll find 10.6 where it begins, we're going to talk about all 5 shapes today, what their volume is, and then tomorrow we'll spend some more time on volume, so we'll repeat some of the same formulas tomorrow. So what is volume? Volume is basically how much the object would hold. If you filled it with something, what would it hold? And what kind of units are you going to use when you do volume? It can't be just flat units. Let me grab some blocks here a second. It needs to be cubic units. Okay, and depending upon what size of cubes, there's going to be more of them if they're small. Okay, this block is like a 1 inch on each side, so this is a cubic inch. Written usually IN with the exponent of 3. So in cubic units in order to fill something. If you have smaller units, like these little blocks, this is more like 1 centimeter on each side. So multiple of those to make the same as 1 cubic inch. Okay, how about a cubic foot? Something that would be 1 foot by 1 foot by 1 foot. I usually have a box around here that's about that size. Yep, back here. So this is about 1 foot by 1 foot by 1 foot. So how many of these would it take to fill this box? What's the conversion between cubic inches and cubic feet? Does it look like 12 of these? Would you fill this box? No, a lot more than that. 12 would just like make 1 row across the bottom. How many rows do you need? 12. That'd be 1 layer. And then how many layers? 12. So what's 12 times 12 times 12? That's how many of these we'll need. We need 1,724 or 8 of these in order to fill this cubic foot. So as far as conversion, it's maybe bigger than what you think because we have to consider the length, the width, and the height. So really by doing what we just did, how do you find the volume of a cube or a rectangular prism? Take length times width, that would give you the base area, and then multiply by the height. So as far as the first formulas, a prism, whether it's rectangular prism or triangular or hexagonal, the same formula can be used for all of those because it's general. The volume of the prism, if capital B is the base area, you simply take the base area times its height, not its slant height. Height as far as how many layers you would need going up. If it's an oblique prism, which they will give you a few of those to do volume of, the height on the oblique prism, just make sure you're using the perpendicular, not the slanted measurement. So prisms, base area times height. Make sure you think of the base area correctly. So if you wanted the specific formula for a rectangular prism, base area would be like length times width. So you could use length times width times height for rectangular prisms. I did not put that one on the wall, I don't think, because it's only for one kind of shape and not a real unique one. I did put the cube one on there because base area, side times side, and multiply by the same side length going up. So if you just cube the length of the side, that would give you the volume of the cube. But again, you could just use for all of those base area times height, whether it's a cube or not. Let's try some examples. Here's just a basic box. What's its volume? Base area times height. Base area times height. And what kind of units will the answer be? Cubic, centimeters cubed, or cubic centimeters. Why don't we use like spheres? Why don't we fill it with marbles instead of there would be gaps between them, correct? But you can measure volume with water. You've probably done that or will do that in physical science class when you're measuring some volumes. That is a good one. Sand could be used, but cubic units is when we're just computing what it is. Okay, our volume there should have been 195 cubic centimeters. All right, another prism, find the volume of a cube. We got two options. You could use the specific cube formula or just a prism, thinking what shape the base is. You need to draw yourself a picture and look at it. Got a number? Go from what's it come out to be? 3,375? Correct. Cubic inches. Okay. How about a right hexagonal prism? Regular hexagon. What shape's the base? Regular hexagon. They didn't give you everything you need, so you're gonna have to work on that regular hexagon just a little bit on the base area. Do your central angle. The opossum in there to make the right triangle. Two chapters. Draw that flat hexagon. Figure out what the opossum looks like. Base area, you have to work on that hexagon. I know some of you are progressing fine, some are stuck. When we start with on those regular polygons, we usually looked at that central angle. Figured out how many degrees it was. 360 divided by 6. So that's a 60-degree central angle. When you put the opossum that you need in there, that divides it, and it's a 30-degree central angle. We have a 30, 60, 90 triangle. We know the whole side is 9. So on the little right triangle, it's 4.5. Your opossum should be 4.5 times the square root of 3. It's a long leg of that 30, 60, 90. So what are we going to need from that? We need the base area. It's a regular hexagon. 1/2 opossum times perimeter. Opossum I found in square root form, 4.5 times the square root of 3. The perimeter would be 9 times 6, so 54. So just my base area is how much? If you don't go to decimal yet, that's fine. If I go decimal, I've got like 210.44. Okay, question on what I just did. That's not the answer, that's just the base area. You got what? 1.6, okay. Yeah, I don't know if you rounded the square root of 3 earlier or something. Okay, and then for the volume, we need to take that base area times height. So that number, if you can keep it in your calculator, that's probably more exact. Take that times the height, how far from the hexagon to the hexagon? 12. So when I multiply by 12, I'm showing 2,525.3. Did I do something wrong back up there again? Okay. Half times 4.5 times square root of 3 times 54 equals times 12. Along the way, I did not do any rounding.
You rounded.
Well, 0.28, okay, I went to the nearest tenth, like it said. And that would be cubic feet for the units. Give me a thumbs up or down. Okay, so you just have to pay attention to what shape the base is, and that volume is just multiplied by the height. Okay, let's go to, I'm gonna skip a few examples because I'd let you use more time on your quiz. A cylinder. Cylinder's gonna have a circle base. So when you do base area, what formula will you use? Always on cylinders. For base area, what shape's the base? Circle. So pi r squared for the base area multiplied by the height. So instead of just base area times height, you can always use pi r squared times height for cylinders. Okay, so find the volume of this cylinder. The diameter is 16 inches, the height is 17 inches. I think on these it asks you to give in terms of pi and a complete decimal. So two forms of the answer. So write down the formula. Volume is pi r squared times height. Diameter is 16, so make sure you got your radius as 8. Ready to see the answer? Yeah. We've got 1,088 times pi, which is like 3,418.1 cubic inches. Yes.
Is that the cylinder, the second, or the bottom, the very bottom one on the question?
Remember
that one?
cylinder?
I was looking at.
Okay, now these have, well, the surface areas have slant heights. So what shapes are these going to be? Those are going to be the cones and the pyramids. So this poster, surface area, lateral area, and volume was for prisms and cylinders that we're currently on. Then we'll get to these other ones. Okay, question on that one. Okay, how about an oblique cylinder? There's really nothing different about that. Find the volume of the cylinder. You got a diameter of 18 this time. The height is 14. It's just measured, not going right through the cylinder. Measured out to the side wherever the 90 degrees would hit. It still asks for two forms of the answer. that one comes out 1,134 times pi and 3,562.6. Alright, so cylinders are pretty straightforward in the formula. I'm gonna skip this one, I think, but notice it's got that wording like the height is equal to twice the radius. I gave you the base area to start with. So you should be able to use that area, find the radius, and then go from there, or maybe not even, I guess you do have to find the radius to figure out what the height is. So if the radius is 11, the height is twice that, so 22, then you've got what you need to calculate. Okay. I put a composite figure in here. What's it made up of? A rectangular prism and what's the top part? So you got a rectangular prism and a what? Yeah, triangular prism, equilateral triangle prism, probably a right equilateral triangle prism because these are rectangles. Okay, so this is what it's a combination of, these two things. Now volume, how much will it hold? Will it hold the same amount that this would separately and this would separately? Is there anything we have to subtract away when we put it together as far as what it would hold? Now, when you hold, like if I had these separate and then I put these together without that, it'll hold the same amount as it would if they're separate. It'll hold the same amount. So you don't have to subtract anything. It's just volume of this one, volume of that one added together. When would you do a subtracting? That would be if you're taking something out. And I guess a taking out might be, I've got a cube and I want to take out like a pyramid amount. I'm going to take that out of there. Like I'm going to squish, if it were filled with water, I'm going to squish that much out. That would be a situation where you're subtracting. It would hold less because this is just air now. That would be the type we would subtract on. You would add, and then just separate. You would subtract, and then it's squished out of there. So this one's just find the volume of those two prisms. Added together. The rectangular prism is pretty easy. Base area would be 8 times 4, and then times 5 for the height. That was 160. How about the triangular prism? Not a right triangle. What kind of triangle is it? It is isosceles, it's even more than that. Yep, with the 8 down here, it's equilateral. You keep working with those a lot. Have you got those in your mind yet? 30, 60, 90 triangle going to the top. 4 there, 4 square roots of 3. Because of where the 60 is and where the 30 is. That's not the apothem, that's the total height. So that triangle for the base would be 1/2, 8 times 4 square roots of 3. That would be your base area. And what are you going to multiply by for the height of that triangle prism? How far from one triangle to the other triangle? This 4. That 4 would be the height. How far from one triangle to the other? Think about my shape here. It's sitting this way. If it were this way, makes sense that this is the height. When it's turned that way, that's still the height of the prism. It's how far from one triangle to the other. It's how many layers there would be. Triangle, triangle, triangle. It's this way, triangle, triangle, triangle. Does that make sense? 4 would be the height. So base area times height. The triangle prism comes out to be, right now I didn't go decimal, 16 times the square root of 3. And then we're just going to add those together. 270.9 when you're done. So this evidently was 110.9. This is the rectangular prism. This was the triangular prism. Look back up here in the form. The 64 was because they had to take the base area. I guess this is where the 110.9 is. This was just base area. You had to take the base area times the height. So where'd the 64 come from? The 16 times the 4. And you're multiplying in square roots. If you don't like to do it in square roots, just grab and do your calculator. Does that come out 110.9? Okay. So this is 110.9. This is 160. So when you add together, 270.9. That makes sense that way? Okay, question on that one. The volumes are going to be easier to add together on composite figures. Not so tricky to have to think of. So here's another composite one. Can you describe to me what's going on there? What do we got? Got a cylinder, and then what? There's a prism inside of it. Okay, so imagine if this cylinder were filled with water. When I put the prism, is there going to be water spilling over? Yes, so we have to subtract the volume of that rectangular prism. So let's start with the cylinder. Cylinder, pi r squared times height. So pi times 3 squared times height. In terms of pi, I just have 45 pi. Then we're going to subtract out the rectangular prism. That's maybe the tricky part. Let's think of it in an easy way, though. It is a square, but a square is also a rhombus. Remember the formula for rhombus that uses diagonals? One half diagonal 1 times diagonal 2. That works for a rhombus. We could use that for this square to make it easy. 1/2 of 6 times 6. 18. That's the base area. And for the volume, we'll multiply that base area times 5. So 18 times 5 is 90. So 90 is what we have to take away from that. You might think, well, that's not big enough. Yes, it is. 45 times pi. And then subtract 90. 540.1. Excuse me. Where'd I come up with that number? I don't know. 51.4. I guess I'm not registering in my mind the decimal that's there. 51.4, does that sound better? Okay, so the composite figures, don't back away from, they're easier. What was the one on the quiz, a combination of?
Yeah, it's the same thing.
Okay, surface area, didn't I have a cone and a cylinder?
That was
A cone and a cylinder. The second bonus was this, but it was surface area. Okay. I was thinking the surface area problem I actually gave you. That would be really easy in volume. You're just doing the volume of the cone and the cylinder and add it together. So let's get those other formulas figured out. A pyramid. Now, pyramid, if you would fill the bottom of the pyramid, the next layer up isn't going to take as much. Right? And the next layer up, less and less as you go. Okay, tomorrow I'll use the water over there to show you. But you're coming in from the sides each way. What it ends up is this pyramid holds 1/3 of what the matching rectangular prism would hold. It holds 1/3 as much. So it comes in from multiple sides. So to find the volume of the pyramid, you take base area times height, not slant height, but perpendicular height, and And then either multiply by 1/3 or divide by 3, whatever your preference is. So the formula is 1/3 base area times height. And it's on the middle poster because that's where our pyramids were at. So let's try the volume of this rectangular pyramid. It has a length of 11, a width of 18, and a height of 23, but it's a pyramid. Not a square base, but a rectangular base. Measurements 11, 18, and the perpendicular height is 23. How much would it hold? Base area is simply going to be 11 times 18. Multiply by the height of 23. You could take 1/3 of it or divide by 3. So you'll probably have a lot of maybe repeating decimals, which you could do a fraction of like 1/3. This one looks like it comes out nice. 1,518 cubic meters. Question how I got that? Okay, if not, let's try another one. This one's in picture form. Find the volume of the square pyramid. The base edge is 9, so the base is 9 by 9. The height is 14. The formula has a 1/3. Up with 378. Can I see thumbs up or down to see who's getting these? Fixing it about right? Okay. Questions to ask? Okay, I'm gonna skip to the cones because we did a regular polygon a little while ago. The height is equal to the apothem, so you had to find the apothem, and then that would be the height to use on the pyramid. Okay, a cone is what I want to get to. A cone is very similar to a pyramid. It has that 1/3. 1/3 pi r squared, because that's the base area, and then times the perpendicular height, not the slant height. Perpendicular height for how many layers there are. So try and do the volume of the cone. That has a radius of 7 and a height of 15. And answers both in terms of pi and in rounded. Some of these in terms of pi will have a fraction because of the 1/3 part. Pi times 7 squared times 15 divided by 3. I guess if you keep it in terms of pi, don't hit the pi button yet. Seven squared times 15 divided by 3. Then times pi to finish it out. Two 45 pi, which is 769.7. Shake your head yes or no if you got it. Okay, volume of this cone. Let's take a look at this one together. So don't start calculating. What's different? I gave you the slant height. So you would need to do Pythagorean theorem and find the perpendicular height before you start it in. I'm going to show that to you so that we can get to that last formula. So 30 would be the correct height to use on this one. At the oblique cone, no different. It just looks kind of weird. The 1/8 is still the height, the radius would be 9. Okay, and starting with circumference. All right, the last formula for the day is the volume of the sphere. It's 4/3 pi r cubed. Okay, so the weird fraction, 4/3 pi times, and the radius is cubed, not squared. Kind of highlight that in your notes. Somebody's going to make a mistake. Okay, don't just square the radius, you cube it. Mainly because think about the radius is going to affect the width, the height, and how far forward and backwards. There's 3 dimensions that the radius affects. So how are you going to calculate with 4/3? You could, if you've got a fraction key, you can easily multiply by 4/3 as a fraction. Otherwise, you can multiply by 4 and divide by 3. But what's our radius here? 12. So probably you just want to try the calculating. 12 cubed times 4/3. That one does simplify pretty good. It just says in terms of pi, but I guess what do you get as a decimal? What else do you get? Well, it'd be like 6 or 7,000. Well, because this times something that's more than 3 is going to be over 6,000. So I'd say you don't have the right number there. It's probably going to be close to 7,000 something. All right, let's do another one. Make sure you can calculate right. I guess this one's a go backwards. Probably going to write it down. Find the diameter of the sphere. The volume is 36,000 pi. So put 36,000 pi equal to the formula. How would we go through solving? Can we get rid of the pi? Yeah, it cancels out because you can divide each side by pi. So divide each side by pi, gets rid of those. How would you get rid of the 4/3? So you might say divide by it, yes. I like to say multiply by its reciprocal. Multiply by its reciprocal. What is 36,000 multiplied by 3/4? 27,000? All right, now, if that were a squared, what would we do? We would square root each side, but it's a cube. So what we have to do is cube root. So you gotta look at your calculator. How can you cube root on your calculator? Is there a cube root key? I think it's supposed to come out 30. There's a cube root key, or there might be just a generic, like multiple root key. So look for a cubed root, and if you don't see that, you probably have a kind of generic root. And you'd have to see how you use that. If you put in the 3 and then press that, and then put the 27,000, that might be how you work it on your calculator. Some calculators you put in the 27,000 first, and then activate that key and put in the 3. So try whichever order. And that's all we're gonna have time for. I need to list everything here. We all go on the side. Or look on your backpack. You want me to list the assignment up here? Okay, page 701. And it's on the sideboard. That page would probably be prisms and cylinders. This one is the pyramids and the cones. And then the last one is the spheres. Same page you worked on yesterday, but now we're doing the volume on 11 and 12. And most of the rest is volume also. Okay, I think I got it there. 11 and 12 with volumes this time. I think you'll find volume easier to think of than surface area. I guess I didn't finish that last problem. We had to get the diameter. We had to take it times 2.